So before we do anything, I want you to do me a favor, right? So head up sets, and I would like 2 sets. I want you to list numbers 1 to 10 for me. All of them, all the way until you reach 10. Actually, I'm gonna be lazy, yeah? I'm gonna list out all for you. Right, let's list all the numbers. Okay, this is your full set. Right, this is a set of elements numbered 1 to 10. I want you to list them after even numbers 1 to 10. Right, just do one paper. Let's do 3 sets there, right? Right, so we have to understand what a set is, right? Let's see if we can list out these. You'll recognize that within a set, we use these curly brackets to represent all the elements inside the set, and then we use commas to separate them. That's okay? Here is what? All the even numbers. So that'll be what? 2, 4, 6, 8, and 10. Here the one multiples of 4, so what it will be? 4 and 8. That's all, right? Okay, nice. Let's take a small note so you know what a set is. A set is a collection of elements. A set is a collection of elements that can be represented within a curly brackets and separated by commas. Full stop. Underneath that, we need to learn about something called set notation. Right? So when you see a symbol, we need to know what the symbol represents, right? So we need to know what this is. Capital U, that is your universal set, right? Kind of U looking like this, that's called union. Leave a little space after to write what it represents, right? Upside down U, that is intersection. Right? Leave a little space in the next day to write the meaning, right? Next, this little symbol here is called complement. Oh, here. This little symbol here is complement. This symbol here means number in set. So this is universal set. They use a U, or sometimes you will see it E looking like this. Right, this is union, intersection, complement. Complement have a little line on top here. Number in a set, and on the outside. This is subset, empty set. Copy them down and leave a little space next to it. I want to give it the meaning of all, right? And I will show you it here one time. All right, so let's start here. What is the universal set? The universal set, write this down. So you just write in. So the universal set has all the elements in a given scenario. All the elements in a given scenario. So in our example, the universal set is equal to the set A in this case. Because in our scenario here, this has all the numbers 1 to 10, right? All the numbers 1 to 10. First one, we need to know what the universal set is, and I gave you an example there. The universal set is A, right? Next thing we need to learn about, what does union represent? Union represent all the elements between, for example, if I wanted B union C, all the elements in B and C without duplicating them. So what would be all the elements in P and C? 2, 4, 6, 8, 10. Here already have 4 and here already have 8. So you need to write it twice. So union for A union C will be 2, 4, 6, 8, 10. So you're listing out all the elements in P and C, but you're not repeating anything. That's okay? So write this down. Union represents all the elements in code sets. Union represents all the elements in code sets without repetition. Without repetition. And then write down the example there. Write down the example B and C. Right, next one. Next one is intersection. So intersection is what they both have in common. Right? What they both have in common. So look at B and C. What they both have in common. They both have 4 in common and they both have 8 in common. So here will be 4 and 8. Okay, write that down. Intersection is what both elements have in common. Sorry, both sets have in common. Intersection is what both sets have in common. Of course, you don't repeat it, right? You just want the elements that they both have in common. Complement now, right? Complement is all the elements, write this one down, all the elements that does not belong to the set, but belongs to the universal set. All right, so what's a universal set in our example? A, right? So what is B complement? Jeremy, what do you think is B complement? All the elements that do not belong here, but belong here. 1, right? 3, 5, 7, 9. Nice. That is a universal. That is a complement. Everything that does not belong to the set. Everything that doesn't belong to B. You clear up? So we understand 1, 2, 3. Let's try number in a set now. So for example, if I told you a number in set C, how many elements in set C? Number means how many elements? How many elements in C? 1, 2. 2 elements in C. So you're writing, you just put in a 2 here. You're not listing out anything, you're just giving them a number of elements. Okay? Number of elements here, 2. Number of elements here, 1, 2, 3, 4, 5. All right. So number of elements, number in a set will represent the total number of elements in a set. Total number of elements in a set. Next one, subset. This one might be a little tricky. A subset is when all of the elements, of one set could be found in an X. So watch this here. What you can see about C30, all the elements of C belong to B. So it means that, watch this here, it means that C is a, it should be a little bit longer, right? I write in my C bar. C is a subset of B. Right? C is a subset of B. So this belongs in this. Okay? C is a subset of B. Empty set means a set with no elements, right? Let's make up one here. Right, let's say multiples of 11 and the values 1 to 10 and p7. Okay, so the number of elements, sorry, number of multiples of 11, 1 to 10, and p7. Okay, and that's a symbol for p7. So these are all the symbols that we need to understand in sets and a Venn diagrams. So there's a way to represent all of this using a diagram. All right. And what I want to show you first is using this example, how to show everything. So normally a universal set is represented by a big box. Right? So a universal set is generally represented by the entire box here. Okay with that? And then all the other subsets, and you'd recognize that these are always subsets of this. All the other subsets will go inside here. All right? So the first thing we do is we have our sets like this. Right? Normally the first thing you do, you write A, you write B, and you check and see if they have any subs. Check and see if they intersect. If they intersect, then you will have this here. And as far as we remember, this here represents what A and B have in common. This here represents what A has in common. This is what B has, is what A has, and this part here. See another part there? That part there represents what we call A only. This part here, B only. Right? And inside here, A and B. Outside here, not A and not B. Right? I want to explain, I want to make sure we understand all those positions in the sets diagram, right? Right, so as I said, the universal set on the outside, that's all the numbers, 1, 2, 3, all the numbers until you reach 10. That's the universal set. Okay, then let's take a look at representing A, and the B. So as I said, whenever you do questions like this, you don't start them up like this, right? If you start them up like this and they have in common, then you have to bring them together. Right? And then if all of this belongs in here, then you draw it in here. All right? So you have to look at 3 scenarios. Scenario number 1 is if they have nothing common. Scenario number 2 is if they have some in common. And scenario number 3, if they have all in common. That's okay? Yeah? So in terms of our A and our B, where do I put B? Do I put it separate? Do I put it like this, or do I put one in the next? Which one? 1, 2, or 3? 3. That's okay? Look at it. Look at why. All the elements in C belong to B. See enough? So because all the elements of C belong to B, everything in C goes in here. That's okay? So we would draw B in here. Right? And A in here. And then we list it out. B is what? 4 and 8. So here's 4, here's 8. 4 and 8 belong to P, and everything else here is A, right? So, sorry, I used the wrong letters. Sorry about that order. This is C and this is B. A is here. Right? Everything in C belongs to P. Right? And B is 2. We already have 4. 6. We already have 8. 10. Right? So everything in here is B, everything in here is C. Where do I put the other numbers? 1, 3, 5, 7, 9. Outside B, but inside here. Right? So you can put 1, 3, 5, 7, 9. You okay with that? Yeah? You follow why I had to put C in here? The reason I had to put C in there is because every single thing, every single element in C belongs to B. Right? If I drew it outside here, it would have been wrong. Okay? It would have intersect and nothing intersect. If I had done it like this, I would have had 2 and 4 here. Nothing here. Right? So when that happens, this set has to go in there. I just take a small note, a Venn diagram. It's used to represent, a Venn diagram is used to represent elements of a particular set based on given conditions. Right? And then copy down those 7 Venn diagrams, and we have to write what each represents. What do you think this shaded area? What do you think this shaded area here represents? Correct. Intersect A, intersect B. Nathan, what do you think this one here is? Union. This is A union B. Nice. Nuria. A union B complement. A union B complement. Very good. If you had a guess, Megan, what do you think number 6 is? Look at what's shaded. It's just A. I don't know. Yes, Megan, it's just A. Right? Only A shaded. So the answer is just A. Right? Hamlet was number 7. Hamlet said B. Very good. And thanks for answering Hamlet. Anybody want to try 4 and 5? What she's saying is this: A complement intersect B. But that's everything outside the A is same. This is everything inside A. A intersect B complement. Right? This is everything inside A, but not in B. Right? This is everything inside A, but not in B. That's the shaded region. Right? And the next name for it, I'm squeezing it in here, that's called A only. A only. Right, Matthew? What do you think number 5 is? B only, right? But how to write the notation? How to write the notation? Look at this one and tell me what to write. Where do I put the complement on B on A? On A. Okay? So these are set notations that we need to know. I want to show you the different next way now to work it out. And I'm showing it too, right? And next way to work it out is to start from what given, but that's if we give it. So for example, if I say the shade A union B, you go down shade A, and because it's union, shade in the same direction, shade B. So that is A union B. That's okay. If I say A intersect B complement, you change the directions when you're shaded, and you're looking for what they have in common. So what is here? This is A and this is B. So I'm going to shade A first. I'm going this way. Now I want to shade B, but I'm not going in this direction, I'm going in the opposite direction. They said B complement. So B complements everything where? Outside of B. Right? Everything outside B. That's okay? So this is B, everything outside, and instead of going this way, I'm going the opposite way. Everything outside B, I'll start here, right? Everything outside B. And because it's intersect, you're looking for where they both shaded, where they both in common, right? You'll see in that area here where they're both in common. So I just taken off where they have nothing in common. That's plenty. I'll also take it off. So they have nothing in common here. And they have nothing in common here, right? No crosses here. So it's outside here. Now see now, when it's intersection, you're looking for where the line cross. When it's union, you're looking for everything. So you could learn them or you could work backwards and get them. All right, so as a quick example, try this here. I didn't give you this one, right? Try A complement intersect B complement. Shade that for me. One example. So let's see how it looks, right? Quickly, let's see how this looks. All right, so you have A and you have B. Here's A and here's B. All right. So we want to shade everything outside A. Everything outside A is here. Everything, huh? Some of y'all will figure it out, which is good. Outside of A is here as well, huh? Look at that. Everything there is outside A. And now you want outside B. So you're going in the opposite direction. Outside B. And then you're taking off when not crossed for the intersection, right? So you're taking off when not crossed. There's nothing crossed in here. There's nothing crossed in here, nothing crossed in here. Right? So it'll look something like this. So what does this look like? This is identical to what? This is identical to something else I made you draw. This one here, right? So this is identical to that. Right? Both of them are the same. All right. So for today, you all understand the notation about the set and being able to draw Venn diagrams. Are you okay with that? So the next day, we will turn it into calculation. Right? There are times that you have to calculate things. All right. So for maths, we'll stop there for today.